Humans have always wanted to break things down further and further and to know what exactly is inside something. For example, what is wood made of? Made of splinters. And then there's little splinters. Well, what are those made of? Those are made of cellulose, which I've depicted here. And what's cellulose made of? It's made of glucose. And what's glucose made of? Well, we know it's made of a carbon atom. And the carbon atom is not just a hard rock, as we've discovered through the many experiments in physics. The carbon atom actually has a complex structure. We have the nucleus made of protons and neutrons in the middle, and we have the electrons orbiting around our nucleus. Right. So this, so far, is our understanding of the atom. But couldn't we keep asking the same question? Just like how wood was not just an element in and of itself, and cellulose is not an element in and of itself, the carbon atom was not a fundamental particle. It's not fundamental in that it was made of something. Perhaps we can ask the same question for these guys. So we can start off with the electron. Is the electron fundamental? Is it made of something? Is there something inside the electron? No. The electron, as far as we know, is fundamental. It is not made of anything. It is in itself the lowest subunit of matter. How about for the proton and the neutron? This is where it gets a little bit more interesting. What's interesting is that if you were to actually break open a proton, you can see that there is something inside. What's inside? These things that we call quarks. Quarks. In fact, in the proton, we have the up, and down quark. So in the proton, we have up, down quark. And in a neutron, we have a down, up quark. So in a neutron, we have a different set of quarks, down, up. And we're going to go into a lot more detail as to what these quarks say and do in further detail, but this is just a quick introductory video to get you kind of thinking about, okay, well, quarks are these things that are inside that of a proton, and they make up the proton. So these quarks create the proton. There's nothing quite inside an electron though. But let's kind of explore the evidence that shows us that these quarks really do exist, so that we can really accept them. We offer physics, chemistry, and math tutoring. For more insightful explanations like this one, head to tutorgum.com.